Hi, my name is Farhsad Ghazi, and we'll be talking about the cloud and secure collaboration in the net. As you know, digital world is radically changing the risk landscape. You have got mobile phones, you've got multiple different entry points, and there are lots of cyber attacks driven through multiple different factors, including monetary, industrial espionage, bad actors, and state actors. So they're all gathered, and there are multiple different entry points into the enterprise data, and data is at the heart of these cyber thefts and criminal activities. So obviously there are lots of good reasons why people want to go to the cloud. There is a lot of cost savings. There's been multiple different studies showing exactly that. For example, one study by a research group has shown over 500K or 80% cost saving per application over a 5-year total. So there are a lot of cost savings, but that's not all. One of the typical and one of the most profound reasons for enterprises moving to the cloud is the use of cloud as a way to elastically and dynamically add capacity. Now that is business agility, and that's speed to market, and causes a flexible and scalable environment for customers that don't really need to address having their own data center, but they like to use what is existing already. Now, moving to the cloud is definitely a very cost saving, and also in terms of business agility, addressing a lot of needs that enterprises do have. However, it also poses a new challenge, and that is, I don't really know where my data is going and how secure is that environment. We do know that the public cloud providers do their best in terms of providing the best security apparatus and mechanism in place, but despite all of that, hackers still find a way to get in. As we always say, it's not a question of if, it's a question of when hack and cyber theft happening. You can try to address as much as possible using the traditional security mechanisms such as firewalling, disk encryption, database encryption, and so on. Regardless, there's always holes that are provided within the security apparatus. Why? Because the fundamental issue is that all these securities are not revolving around the data. And so, in order to address the data-centric security in the cloud, we are talking about how to best protect the data. At the heart of this data-centric security that I'll be talking about is the way and the mechanism in securing your data, no matter where it goes. And cloud is one particular place that a lot of customers are using, our customers and enterprises are using to move their data to the cloud. But also we have seen similar trends in terms of addressing the big data and the data that is moving to the big data. And so what we are going to be presenting here today is a unified solution architecture that is really revolving around the data. Not about firewall, not about database, but about the data. And not just every kind of data. It's the sensitive data elements that is really important. What is the point of having all this data if you can't make sense and find trends from it? So business intelligence and analytics are core fundamental components of all enterprises. We are living in a data-driven economy. We are living in an era that having access to the data is paramount, and the data is really critical in figuring out customer behavior, trends, market conditions, and customer preferences over multiple different things. And for us to understand that, it's very critical. However, typical encryption doesn't lend itself for the data to be reused. And that is a fundamental issue with encryption. It's great, it's secure, however, it's so burdensome. The burden and the overhead in having that encryption is so much that you end up not using the data anymore. And what's the point of data again? We'll be introducing the format preserving encryption, secure stateless tokenization, and above both of these technologies, the stateless key management. that really addresses some of these fundamental challenges within the encryption and data protection. If we talk about encryption, what is a typical issue with encryption? That if you have a name and you encrypt it using, for example, AES CBC mode, you get a big blob of random characters. It's very secure. However, you cannot use this data anymore. Using a format preserving encryption, we maintain the characteristics and the format of the actual data elements. If it's name, it's going to look like a bunch of characters again. Of course, it will not be the original Steve or Richard, but it'll be something else entirely made up of those characters. If it's an email, it's still going to look like something at something dot something. So if there are applications that are still expecting an email, they can continue to operate. The problem with the encryption is once you encrypt it and you pass it along as the valid parameters through other middleware that do not actually need the data, you're going to have problem because applications are going to reject it, and naturally so, because they don't look anything like the data they were expecting. It doesn't look like date of birth. With format preserving encryption, you ensure those characteristics are maintained and carried throughout the encrypted values. So you get an encrypted value, we call through our format preserving encryption, preserves the format, preserves the length. And it can be used in the middleware application, and it can be stored within a database. That is a very critical and fundamental component. You can store the data in its encrypted format, and while maintaining the ability to use that in trends and business intelligence and analytic tools. Overlay that with our stateless key management. And our stateless key management addresses some of the most fundamental challenges in the PKI or public key infrastructure. As everybody in the encryption and security industry is aware, PKI is completely broken, has been for a while, and it's really one of the most difficult challenges to solve. For example, in a typical asymmetric encryption, you have a private and public key pair. And the private key is for me to decode any messages that a sender sends using my public key. So the issues are, how do I get my public key to the sender? The sender has to encode it and send it back to me. And how do I secure my private key? If I lose my private key, I can no longer access those encrypted files. And if somebody else gains access to my private key, they can basically decrypt and read all my encrypted messages. So we have come up with this innovation, and we have lots of patent across all of these things, which deals about the stateless key management. Stateless key management fundamentally uses multiple different parameters, including the identity as well as a few other important factors, to come up with just-in-time key derivation. So any encrypting entity would basically ask the stateless key server to provide a key just in time when they need it, and that key does not need to be saved. Hence, it is stateless. And therefore, it's a fundamental advantage of having a stateless key management that is not requiring you to store your keys in a vault and safeguarding them. And this also lends itself to a scalable model, especially if you're talking about the Internet of Things, the cloud, and so on. You're dealing with humongous number of connected devices. In the IoT, for example, you're looking at the connected cars, you're looking at connected homes, smart meters, everything else, and all of these are quite critical to ensure they're receiving the right data and they're also sending the right data, and that data is also safeguarded. They could present major challenges if, for example, a connected car, is hacked. Obviously, we have seen lots of stories around it. GPS of that car could be potentially misused and used. So these are all the challenges that we are dealing with, and as a result, this data-centric security as a whole, which really revolves on the three main pillars, it is format preserving encryption, secure stateless tokenization, and stateless key management, provides that data-centric security for the data. Now, the data can be on one public cloud provider or could be on another, and its encryption, regardless of where it goes, is exactly the same. It could even travel across multiple different environments. For example, it could be coming from an IBM ZOS, from HPE Nonstop, from a Teradata solution, and goes to the cloud. And it could be going to, for example, one public cloud like AWS, or to Azure, or to private clouds such as our Helion offerings. And it doesn't matter. The data is encrypted in the same manner, and that data can be exchanged. And there's something called referential integrity, meaning that there is a unique one-to-one mapping between the ciphertext and the clear text, between the original value and between the encrypted value. And therefore, that encrypted value always represents the original value, and it can always render the original value back. And so that is critical in addressing the single unified security solution regardless of your environment, and it addresses the secure collaboration.